Hello there. We're going to look at an example here of how to find the rate if we have a compound interest situation and we're given how much is deposited and then what our goal is. Now with this, we want to make sure that at first we remember the formula for the compound interest situations, and that's A is equal to the principal that we deposit times a quantity 1 plus the annual rate in decimal form divided by the number of compounding periods per year to the number of compounding periods per year times time in years power. Now, when we look at this, we want to make sure we read through the expression or the problem and see what we have. So to save for a future expenditure, $6,000 is deposited. So at first, when you're looking at that future expenditure, if you just focus on that and forget to pause and then read what it says after, you might be setting up your values incorrectly from what you have. Well, $6,000 is what's deposited. So the principal that we're depositing is the $6,000. So be careful on that. Now it's into an account that pays annual interest compounded semi-annually. Well, that means 2 times a year. So that's our N. N is 2. What rate? So what annual rate means that we're trying to figure out what the R is required to meet the investment goal of $9,500. So that means the amount we're trying to attain is $9,500 in 8 years. So time, and it's in years, so T is equal to 8. Now with writing all of that down and then also recognizing we want to write our final answer to the nearest hundredth of a percent, I'm able to now start to set everything by substituting it into the equation. So our amount is the 9,500 is equal to the principal is 6,000 times 1 plus R we don't know, N is 2, and then to the 2 times 8 power. So the first thing we're going to do is just simplify anything we can, and here the only thing we can simplify at this point is the exponent. So we have our 1 plus R over 2 in the parentheses to the 16th power. Now to solve for R, this is a little bit trickier. One of the first things we want to do is divide both sides by the 6,000. That's not in the quantity that's being raised to the power, so that helps us get the expression with to the power on one side. So when we divide both sides by 6,000, we can simplify the fraction, but we don't want to approximate it as we're doing the calculations, or that can propagate error. And so simplifying this, we get that fraction is 19/12. And then on the right, we have the quantity 1 plus R over 2 to the 16th power. Now our exponent is a number, so we can take that root of both sides. We're going to take the 16th root of both sides, and it's an even root, so we would put the plus or minus, but because we're talking about interest rate, only the positive situation is considered. So I'll go ahead and scratch that out. So you want to remember to write it, but then evaluate whether it applies to your particular situation. Now again, so that I don't propagate error, I'm going to keep writing that 16th root of 19/12. And then on the right hand side have the 1 plus R over 2. Now we're solving for R. The next thing we want to do is subtract the 1 from both sides. So I have the 16th root of 19/12 minus 1 is equal to R over 2. And then multiply both sides by 2 to solve for R. And I get R is equal to 2 times the quantity, the 16th root of 19/12 minus 1. Now when we go through and get a decimal approximation of this, R is approximately equal to 0.058274378. And I want to change that into its percent form before we approximate it. So we have R is approximately Remember to change it to percent form, move the decimal point 2 places to the right, and then put the percent symbol on. So 5.8274378%. And now round to the hundredth, because it says hundredth of a percent. So we want to do hundredth once it's in percent. So our place value we're rounding to is the hundredth of a percent. And when we look, 7 would bump that up to 3. So I have my rate is approximately 5.83% that we would need in order to attain our goal.